So quick question, how many of you have worked on any of these format? Can I have like hand raised? Oh, so almost all of us have worked in all these kind of different data formats on our daily basis. So now we know in this modern integration world, all the applications and components are connected together, exchanging the data via APIs. And with all of these interactions and communication, one thing is very important, and all of these things rely on these data formats. Either it is XML, YAML, CSV, JSON, and any other. So the challenges that we face right now is basically we get a data and we want to extract the data from source application, and then we want to transform it into another format. By transformation, sometimes we merge it, aggregate it, enrich it, summarize it, or filter it. And by doing that, then we load that data into our target location. So that process we all know is called ETL, extraction, transformation, and loading. And this is a central process of any interaction, any integration. Let's take a quick look to this example where we have application A and application B, and both of these applications storing the same customer credit card information, but the structure is slightly different. And to ensure that critical data isn't lost, information from application A needs to be reorganized to fit the data structure of application B. For example, you can see in application A, it has like cardholder first name, then cardholder's last name. It's separated into first name and last name, whereas application B has cardholder complete name. Similarly, card type and card number is all together in application A as a card information, but in application B, it has a card type separated out with card number. So these kind of pain points we face on the daily basis where we have to reorganize one data structure into a different so that we can feed into a different application or API. To resolve that pain point, we are introducing DataWeave. DataWeave is a programming language designed by Mulesoft in 2015 for mainly data transformation. Now, what is data transformation? Data transformation is nothing but reading, parsing data from one format, manipulating whatever we like as a desired output, and then writing it out, serializing it into a different format. So that's data transformation. Now let's see a couple of features of DataWeave. So DataWeave is a functional language. For example, functional means it can create and apply functions. We have immutable variables that provide stability to our code. It's a functional language, that's why we have concise and clear code. And the function signature also provide little bit transparency. Now the second feature is DataWeave is a statically typed language. And what does that mean? Is type checking occurs at the compile time instead of the runtime, so that errors are detected earlier at the compile time, and then variable assignments are static, and this entire process produces optimized code. So now we know a little bit high level of what is DataWeave, what is its characteristics. Now take a dive into how does it work. So basically it has three sections: reader, DataWeave script, and writer. So when the DataWeave receives data, it sends to the reader, and reader parse that data into a canonical model. Canonical model is nothing but the internal data model of the DataWeave, where it retains all the property of the data format, all of its hierarchy structure. So then this canonical model is passed to the DataWeave script, and then DataWeave scripts transform the data and generates the output into another canonical model, and that canonical model is then passed to a writer, where writer is responsible for serializing the model into a desired output data format that we want. So that's basically how DataWeave works. What is the DataWeave purpose? So the DataWeave purpose is to help developers focus on actual transformation logic instead of worrying about reading, parsing, writing, serializing the data, or also thinking about how we can transform it in a performance efficient way. All of this is taken care within the DataWeave. So in conclusion, DataWeave is here to make our life easier. Now let's take a couple of examples, high level, what DataWeave can do. So here we can see it can easily reformat the data from JSON to CSV, with one line of code. It can handle a lot of different formats such as JSON, XML, CSV, YAML, and many more. Now if we talk about the query, we can easily navigate through data into a structural way by combining different DataWeave selectors. No matter how much nested the data we have, we can easily query with DataWeave. For example, we can use these selector, and what we'll talk about later in our demo, we'll go through in depth of all these selectors. Now if we talk about the mapping, we can create our brand new structure by simply defining the structure and combining multiple queries. For example, you can see here, we have products, product names, and then we aggregated that into a ticket list as an output. If we talk about transformation, we can easily combine functions to completely reshape the data. Our standard library covers filtering, mapping, grouping, reducing, and many other common functions. So now we have learned about DataWeave, and we have also seen the examples. Now the question comes, why should we use DataWeave? We can proudly say that DataWeave is industry proven, and it has empowered trillions of transactions on mission critical applications within the Mulesoft platform from 2015. So now we can confidently say it can easily handle any of our use cases. Now DataWeave was initially designed for basic transformations such as simpler queries, simpler building expressions, but then we quickly saw users started enjoying it and realizing its potential. And as we have already discussed, the problem of data transformation is not just restricted to the integration world of MuleSoft. Why not make DataWeave an open source language? So that's why we are making DataWeave an open source language, and we would like to invite everyone to take advantage of this language and help us grow this language further. Now let's discuss what are the resources available currently so that we can use, try, test, experiment, and code in DataWeave. So currently we have DataWeave Playground, which has two sections, tutorials and playground. In tutorial section, you'll find out from basics to advanced tutorials to learn the DataWeave language, and then playground section, you can try different script with different input data to see what is the output, so output data format, so that it will help you experiment and learn more about the DataWeave. Now we also have command line tool. You can install that command line tool from GitHub, which will provide you all-in-one functionality, and you don't need to have multiple command line tool for different data formats. Everything will be there in one command line tool, that's DataWeave CLI. It also provides you a proper language feature such as IDE support, testing, and debugging. Now the third resource is Visual Studio Code extension that we will right now work to test the DataWeave. You can download the Visual Studio Code extension from the marketplace, and then you'll be able to use awesome features like auto preview, test scenario that we're going to talk in a minute. Now let me show you some fundamental characteristics of this language and how we can use the Visual Studio Code extension and command line tool to code or transform any data format. Let me know if this is visible from the back, or do I need to increase the font? Thank you. Okay, so we have a couple of modules to discuss what is exactly DataWeave language. So first, look at the script structure. The script structure has mainly 4 statements. The first one talks about the DataWeave version. So first talk about this 3 dashes. It looks odd. Why we have these 3 dashes? These 3 dashes separates the header or directive of our data transformation language with the final output what we want to see. So right now, in the header, we have 3 statements. The first statements talk about the version of DataWeave that we are using, and currently in Visual Studio Code extension, we have 2.0. The second statement is an input statement where you have to define the variable name, MIME type, and then reader's properties are optional. The third statement is an output statement where you have to just define the MIME type and the writer's property. Writer's properties are optional. That contains headers as true or false. Now, after this separator, we have the place where we can write any logic that will be sent to the writer to get serialized. For example, we use this payload. Now let's see what is this payload. It's just a JSON format. It has message as hello world. And now we are trying to see that output directly. We also have this auto preview feature enabled in Visual Studio Code, where whatever you write, you can easily check it from the right hand section actively. Now we know the script structure. Let's talk about the output transformation. So now again, we have 3 lines, headers, DataWeave version 2.0, input, payload.json. Now let's look at that payload. It's basically a JSON format which has an employee 1, and within that employee 1 key, we have first name, last name, gender, age, address, phone numbers in a list with different types, and is employer as true. So now we know this input, we want it from the payload, and it's in JSON format. Now if we want to convert into XML, we have to just write XML, and that's all. If we want to change it to YAML, we can easily change it in YAML. Now if we talk about CSV, we all know CSV is comma separated values that has row by row structure, so we cannot have it into a particular hierarchy. So if we try to convert that, it will give me error because it's not in a list format or array format. So if we give, for example, phone number, it can automatically convert that list, that array, into a CSV format. Now, the default property that we talked about, writer's property, that's optional. If we see headers, by default it's true. We can always make it false, and now we don't have header here. Okay. Now, if we talk about data types, we have support for all different data types. For example, we have this type of function that tells us what is the data type we used for this particular object. So now, type of payload, and we know the payload is the same JSON object. So it shows me the object. Now, if we go through it, and if we want to do the last name, it's a string, age. So we all know it supports basically all of the basic data types. Now, there's one thing that I want to show here is this now function that gives current date time. And if you check, we have a list of huge date time data formats that we can use in our any JSON or any data format. Let's talk about the operation. We have all mathematical operations. There's one important operation that I want to show. It comes under equality and relational operator, where it checks the similarity. Now, 24 is a string, but if it checks and it converts that string, so yeah, if you want to convert that string and then validate whether both are true, we can easily check using this. Let me, this, yeah. So it gives me true. Now, if we change any of this as 25, it will give me false. So it's a similarity match. And then we have a logical operator, that's 21 is less than equal to false, less than equal to 10, we get false. We can also add different objects into our JSON payload. For example, in our payload, we added employee ID. So that's, we get it at the end. We can also remove couple of objects using minus operator. So gender address is the list of 2 objects that we want to minus from the key. So you can see the gender and address is removed. And we can also combine it by adding multiple and removing multiples. So that's the basic part. Now the interesting part is the selection. Let's talk about single value selector. We have already know it's a simpler thing where we just put a dot and do all the selection. We know the payload. Now in this payload, I want to highlight one thing. We have 2 ages, age 24, age 26, and then I also added one more element, age, within the 4 numbers as 27. This is just for the demo purpose where I want to show how we can extract age later on. So now if we want to do this multi-value selector, if we do age, we will get only first age. Now if we do this multi-value selector, that's asterisk, it will give me the list of all ages in that particular hierarchy. So 24 and 26. So basically in this employee 1, inside employee 1, it gives me both of them, 24 and 26. Now we also have a descendant selector. For example, if we do dot dot, that goes to every hierarchy inside the object and then pick up the top first element, the value of top first key. So for example, if you see in the payload, we have 24 is the first age within employee, and then inside employee there's a phone number, and within phone number there's also 1. So that's why it picked 24 and 27. And it left it out this age 26. Now how do we get both of them? Basically combining both multi-value selector and descendant selector. So if we do that, we get all the value of ages within every hierarchy. It will go through every path and get all the values. And then we don't need to give any path. At the top level, we can always have this, and it will go to that particular field and check in every hierarchy and find the value. So now if we see the index selector, it's common in all of the languages. Phone number is an array, so we can give it to 0, it will give us first element. If we give it 1, second element, we can always change from range 0 to 2, it will give me all 3. 0, 1, 2, 2, 0. It's common. Now if we talk about functions, we have a smaller function statement. We can have fun and then add x and y, and it will give me the result by adding x and y element. Now variable, we can define variable that's greeting good morning as a string. Now if we talk about the difference statement, difference function, we can easily create it using that path, but I just wanted to show the do statement. So do statement is within a particular function, you can create your own local scope variable. For example, num1 and num2 are the variables that we created within the function, and its scope is within that separator line. So we have a small separator line within that function where we define the scopes, and then we just subtracted it. So basically it's same. And it will work as adding 3 plus 4, 7, and it will work 12 minus 5, that's 7. Now we have the logical if-else statement. If you see, we have a variable called price 160. If the price is less than 50, it will return the buy statement. Else, if the price is greater than 500, it will return the expensive statement. Otherwise, it will return drop few item. Now it's 160, so it's between 50 to 500. It gives me drop few items. Now if we make it 1600, it will go to that and then print expensive. So now with this 5 top module, we got little bit idea of how DataWeave works. Let's go to little bit advanced and then talk about the type creations. We can create types and restrict them. For example, we have HTTP method as a type where we restrict them. We can only have get, post, put, delete value for that type. And now we defined a variable called method that is a type of HTTP method. Now we cannot add anything other than those 4 values. So if we say small letter put, it will give me expecting type HTTP method but got put. So it's not correct. Okay. And then if we talk about, this is an open object where my name has a parameter, an object which has a name key, and then value can be string, anything. If we want to change that variable, and if we want to make it close object, for example, like this, that means we only want name key. We do not want anything up other than the name key. So that is giving me error for the L name because it is a closed object. We also have a optional object, for example, age, question mark. So we can have age or not, it will print the value. But if we have age, we cannot add it as a string because now it's an optional, but if we have an age key, we have to put the number because it says expecting type number, but you got a string. Similarly, we have this multiple value type where we can have age as a multiple one. And still, if we say age is a multiple, but all should be numbers, so it cannot be like it cannot be string, so it will give me error. We can have multiple age, but that should be number. We can also check that type and see if whatever we are adding into the variables and functions and types, the output section only gives whatever is after the separator. So it's only giving and printing the employee name. Now we can also check if employee name is my type, true, that is basically my name type. Let's look at this flow control where we have this function called a status message, which takes users and as a variable which has a user type, which is this, which has name, last name, age, status, and location. And the status also has a status type. That is, either it should be active or inactive. So once we take that, this function will check the status, and if it is active, it will print continue session. Otherwise, it will print, if it is inactive, it will print welcome back. So here we send the presenter as a variable which has a status as active. So it printed out the welcome, the continue session. So basically it's just to show how the control is going and flowing through all functions and checking and restricting by checking the types. We also have an update function. So here we have a variable called sample, which is an object type which has name, age, programming skills with the different languages. Now let us suppose we want to change the age. We can simply use the update function where can we give case as age and change it to 30. So now it's 30. And then the programming skill, change the 0th element, the first element, to Ruby. Now it's Ruby. What if we want to do some complex updation? Yeah, so here in this second example, we created num as a variable which is pointing to dot age, and we said check that dot age. If that age is greater than 40, then take that variable, take that number and minus 30 from that. Now you can see it's 32, so it did not went into that statement. If we make it, for example, 42, it will go to this statement and minus 30, so it will give 12. Similarly, we have this programming skill array. We assigned it into a local variable called PS, and then you can add an element into the PS. Instead of removing C language, just add one more language called Perl into the list. So that's how simpler update function we can use. Okay, if we look at this data, let's take a look of this payload. We have a huge payload of COVID data which has date, GeoID, county, state, cases, and this is a CSV format. And if we see how many rows we have around 97,791 rows. We can easily do the filtering with the help of filter function. So for example, we wanted a Texas, and then we wanted this date stats, and the first element. We can easily change it to first 5 element, and it will give us the first 5 element. Now if we want to change any filtering, we can quickly do it with DataWeave, and it will within microseconds filter it out, the huge payload, and give the final result whatever we want. Now we also talked about creating our brand new structure or changing it. With the help of mapping function we can do it. Let's take a look at this payload. We have result, extension, and within extension we have this statistics. Now statistics contain a statistic name and value. What if we want the key as the name of the statistic and then value as the number? So like this. We used it, one mapping function, and change it from statistic name and value as this object, so that we can completely create our own key and define our own key value structure. We can also do that in a simpler version with the help of $. Now $sign is basically removing and reducing the number of code in DataWeave by removing that lambda function. Now this is basically a lambda function, and we removed it, and then use dollar to use the first argument of it. That's basically this payload. So it gives the same result with the same one. So when we try to learn more in advance, we understand that we have this good features like single dollar, double dollar, which we can use to reduce the number of code and get the output what we want quickly. Now we have this last exercise, and this is really good, and I really wanted to show you all about this curl statement that we talked about. We have DataWeave command line tool, and once you install it, we can take any API. For example, we have taken this API. This is a Yep. So this API is basically boardapi.com. It's an open API. It's a GET call. Whenever we hit that API, it will give us one activity that if we board, we can do it, and the type of that activity, the participants, price, and then some other data. Every time we hit it, we get different activities. Watch the sunset or the sunrise. Start a collection. So now we will use that API and use the curl command to call that API and take the response and use that response and convert into XML using DataWeave. So for here, we did the curl to this API, get the response, JSON response, and then use the DataWeave command line tool to convert that into output XML, and then the second separator that we used, and we added all the payload inside the root element. So if we see, we got all the activities, everything is there, but that's inside the root element, and it's converted into XML format. And it will give me new activity every time. Make a new friend, take your cat on a walk. Now, the other thing is, what if we have a DataWeave stored in somewhere as a script and we want to run that into a particular API's response? So to do that, we can easily use this curl, get the API, and then DataWeave, run from the file which is stored in this module. src main, that's this path, and basically this is the name of this curl module, this one. Now in this module, we only have input, output, and then this section, it tells me convert the output into XML, and then only have this root element and only have this payload.activity. So yeah, it did that, converted into XML. This is the 2-line output, XML with root element, and the activity is shop at support your local farmers market. And yeah, we have this command line tool in GitHub that you can install. Let me go back. Okay, so now this is the landing page of DataWeave, dataweave.mulesoft.com, and we recently launched it so that all of the open source resources are available in this website. You can go and check it out. It will point you to all of the resources that we have, for example, Playground, Visual Studio Code, Command Line Tool, and Slack. We have a dedicated Slack space where you can write any questions, any discussions on DataWeave whenever you try an experiment. And if you have any questions, I'll be around for a few minutes. And you can also reach out to me. This is my email address, pranjal.tripathi@mulesoft.com. You can also add any questions, any discussion into that Mule Slack dedicated space. And thank you all, everyone, for joining this session. Have a great day at ATO.